Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about how to solve the problem number 16, which was a numerical based on the decay constant, and now here we are going to talk about how to solve the problem number 17. So let us find out what is the question that has been asked and let's see how we can solve it. So friends, here the question which has been given here is the half-life of radon is 3.82 days. By what time would 99.9% of radon will be decayed? By what time? That means they are asking about time in which the change will occur from 100% to 0.1%. That means 99.9% of the substance or of the isotope which has been decayed. So they are asking about that what is the time that would be required to convert the particular substance, especially the radioisotope, from 100% to 0.1%. Let us understand what are the data that has been given in this question. So first of all, the half-life for the radon is given as 3.82 days. So that means I could write it over here as T half is equals to 3.82 days. And here basically they require time, that is T. But suppose what if we consider the initial amount of the substance as 100%, that is the radon, and we could find that is if 99.9% of the radon is being decayed, then the amount which is left here is, that is 100 minus 99.9, which is 0.1%. So here we have the value of N naught, here we have the value of N, as well as we have the value of T half. So with the help of T half, we can easily calculate the decay constant, and from that decay constant we could be easily finding out what is the time required to convert from 100% of the radioisotope to 0.1%. So let's see how we can calculate it. So for that, the formula is very much simple, that is T half, or the half-life period, is equals to 0.693 divided by lambda, and here basically we have to find out the decay constant. So therefore this is 0.693 divided by the T half. So the T half has a value which is given here as 3.82 days. That means the decay constant will have a unit in day inverse. So let's see what is the value we could get here. So we have got the value as 0.181 day inverse for the decay constant. But this is not the final answer. We have to calculate the time that has been required to convert 100% of the radon to 99.9% if it has been decayed. So let us find out what is the time required for this change. So for that we have the formula, that is lambda is equals to 2.303 divided by time log to the base 10 of N naught divided by N. Since we have to calculate the time, so therefore T is equals to 2.303 divided by lambda log to the base 10 N naught divided by N. So let us substitute the values. So for that we have 2.303 divided by lambda, that is the decay constant, which is found to be 0.181 day inverse log to the base 10 for N naught, which is found to be 100, divided by N, which is found to be 0.1. So let's see what is the answer we could get, and the time in this case it will have a unit of days. So we have got the answer as 38.17, and that's it. So this is how basically we can calculate and we can solve this kind of numericals. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope you have understood this numerical, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.